There is a student in almost every math classroom who finishes first, always, before the pencils are even fully out, before the room has settled in to the quiet hum of thinking. That student is done, paper flipped, arms crossed, and waiting. And here's what typically happens next. The teacher glances over, nods, maybe says, "Great, you get started on the extension," or "Go ahead and check your work," or simply moves on because the student finishing first is a signal that the lesson is going well and that the content landed and that at least one person in the room got it. And here's what I want to ask you today. What if that signal is wrong? Not wrong in the way that we usually talk about fast finishers and not the conversation about what to do with them while everyone else catches up. I mean wrong at a more fundamental level. Wrong about what finishing first actually tells us. Wrong about what speed in the mathematics classroom actually measures. And wrong sometimes about whether that student who is sitting there with their arms crossed actually understands what they just did. Welcome to Show Me the Math Receipts. I'm Asali Smith, founder of Number Navigators, and this is episode 12. Going to talk about the fast finisher myth, the belief that speed signals understanding, that finishing first means knowing most deeply, and what it costs us when we build classrooms around that belief. So let's get into it. Over to you, Josh.
It's time for Math Joke of the Day. What is a teacher's favorite season? Summer. But I'm bunching.
Thanks, Josh. Okay, let's go. Let me name the belief clearly before we examine it. The belief is this. In a mathematics classroom, the student who finishes fastest understands best. Speed is a proxy for proficiency. And so the fastest finishers get extension work, get called on first, get the quiet nod from the teacher that communicates, yes, you are the one that has it. And here's what that belief produces. A classroom culture where speed is the visible marker of mathematical ability, where students who work slowly or who take their time, who check their reasoning, who sit with a problem before communicating a strategy, they learn that their pace is a liability, where the race to finish becomes its own curriculum, running parallel to the actual mathematics and often overpowering it. We talk about this in episode 2 when we get into the timed test and speed anxiety talk. Today is that natural extension of that conversation because the fast finisher phenomenon is not just a time test problem. It lives in every independent work period, every warm-up, every moment a teacher scans the room and uses pace as a read of understanding. So the question worth sitting with is, if speed is not a reliable signal of mathematical depth, and the research suggests it often is not, then what are we actually seeing when a student finishes first? What are we missing? The research on speed and mathematical proficiency is consistent in a way that really should give us some pause. Joe Bowler's work at Stanford, which we've referenced a number of times across this show, has documented extensively that students who are mathematically flexible, who can see problems from multiple angles, and who move between strategies fluidly are not always the fastest. In fact, some of the most mathematically sophisticated thinkers are slower because they're doing more. They're doing more thinking. They're checking. They're questioning their own reasoning. They're asking themselves whether the answer makes sense before they write it down. That process takes time. And in a classroom that reads speed as success, those students often feel like they're falling behind, even when they're doing exactly what mathematical thinking requires. Robert Sigler at Carnegie Mellon has spent decades studying how children develop mathematical strategies. And his research shows that the students who develop the most robust and flexible mathematical understanding are the ones who work through multiple strategies over time, not the ones who latch on to the fastest procedure and then execute it efficiently from the start. Efficiency is a destination, not a starting point. And the students who arrive at efficiency most quickly are not always the ones who understand most deeply. Sometimes they're the ones who found a shortcut. And shortcuts, as we talked about in episode 4, are only as good as the understanding underneath them. And then there's the work on metacognition, the research on students who monitor their own thinking as they work. John Flavel at Stanford showed that the habit of self-monitoring, of checking in with your own reasoning, of pausing to ask, does this make sense, is one of the strongest predictors of mathematical success over time. And self-monitoring is not fast. It's deliberate. It adds time to the process. And what that means is the students who are doing the most sophisticated cognitive work in your classroom may not be the ones finishing first. Let me show you what this can look like being played out in a real classroom, because I want you to be able to see this from both sides. What the fast finisher is sometimes doing and what it sometimes costs everyone else. Here is the fast finisher who has genuine mathematical understanding. This student has developed strong number sense, built solid conceptual foundations, and can move through a problem efficiently because the understanding underneath is solid. When they finish first, it reflects real proficiency. And the question for this student is not whether they understood, it's whether the task was rich enough to require their full mathematical thinking, or whether they were able to bypass the thinking entirely because the task only required a procedure. And here is a fast finisher who does not have deep understanding. This student has memorized a procedure efficiently. They execute quickly, they finish first, and when the teacher asks them to explain their reasoning, when the follow-up question arrives, the way it arrived in that 5th grade classroom we talked about in the last episode, the explanation is thin or non-existent, or reveals a misunderstanding that the correct answer completely obscured. Both of those students exist in your classroom. And from a distance, from across the room, from a quick glance at a flipped over paper, they look identical. The difference only becomes visible when you ask the question that goes beneath the answer. And most classrooms, most of the time, are not asking that question of the fast finisher, because the fast finisher has already signaled, I'm fine, everything is fine, I have it, move on. And so the myth perpetuates itself. The fast finisher finishes first. The teacher reads it as understanding. The fast finisher learns that finishing first is what success looks like, and nobody ever finds out whether the house that it's built on is solid ground or on procedure alone. So here's what I want to offer, because I do not want this episode to be about doubting fast finishers or making them feel like their pace is suddenly a problem. Speed is not the enemy. The misreading of speed is. And what that means is that this conversation is not about slowing fast finishers down. It's about deepening what finishing means. The most powerful shift a teacher can make for a fast finisher is to change the finish line. Stick with me. Not you're done when the answer is written. You're done when you can explain it, represent it in another way, connect it to something else, or extend it to another, maybe even harder question. That shift does two things simultaneously. It tells the fast finisher that the answer was never the point, the thinking was, and it makes visible immediately whether the speed was built on understanding or on procedure. Because a student who genuinely understands the mathematics can explain it, extend it, connect it without hesitation. And a student whose speed was procedural will hit that second question and slow down. Not because they're less capable, but because the second question requires the understanding that the first question never asked for. That slowdown is not a failure. It is data. It is the most important data in the room. And the teacher who creates the condition for that slowdown is the teacher who actually knows what their students understand, not just what they can produce. If you are a classroom teacher, I want to offer you one concrete reframe that you can use this week. The next time a student finishes before everyone else, resist the impulse to move them to extension work immediately. Instead, ask Ask them one question, not can you check your work, because checking usually just means doing the same thing again. Ask them something that requires genuine mathematical thinking. Can you solve it in a different way? Can you draw what's happening in this problem? Can you create a similar problem that would be a little harder than this one? Those questions do not punish the speed. They actually honor the speed by treating the fast finisher as a mathematical thinker who is capable of going deeper, not just faster. If you're a math coach, the fast finisher is one of the most under-examined students in classroom observation conversations. When you're debriefing with a teacher after a lesson, ask about them specifically. What did the fast finisher do after they finished? What did the teacher learn about their understanding? Those questions open conversations about what the classroom is measuring and what it might be missing. If you're an instructional leader, I want you to look at your extension tasks, the work students are given when they finish early. Does that work ask for more of the same thinking at a higher level? Or does it ask for a different kind of thinking entirely? The kind that reveals whether the speed was built on depth. The quality of your extension tasks is a direct reflection of what your school believes about mathematical proficiency. And it's worth examining honestly. And if you're a pre-service teacher, before you ever hand a fast finisher an extension worksheet, ask yourself, what are you trying to learn about that student? Because the extension that keeps them busy is a very different thing from an extension that tells you something true about their mathematical understanding. Design for the second one every time. So here are your Wednesday morning receipts. 3 things this week. Number 1, change the finish line. Pick one task this week and rewrite what done means. Not when the answer is written. Done means you can explain your reasoning, show it in a different way, write a question you still have about that mathematics. Post that definition of done before the task begins and watch what happens to the room, including what happens to your fastest finishers. Number 2, ask the second question. Every time a student finishes first this week, ask them one question that goes beneath the answer. Not, is it right? Something that requires genuine thinking. Why does it work? What would change if the numbers were different? How would you explain this to a student who got it wrong? 2 minutes, one question, real data about what that student understands. And number 3, notice who you're reading as successful. For 1 full week, pay attention to whose work you glance at with satisfaction and whose work you stop to examine more closely. Is pace influencing that reading? Are you more likely to trust the work of students who finished early? That awareness, honest, private, uncomfortable if necessary, is the first step towards a classroom where depth, not speed, is the signal that you're reading. So here is what I want you to carry out today. The student who finishes first is not automatically the student who understands most. And the student who takes the longest is not automatically the one who understands least. Speed is real information, but it is not the information that we usually think it is. And the classroom that treats finishing first as the goal is building a culture that will cost students, all of them, the fast and the slow, something that they can't afford to lose. What we want is not a classroom full of fast finishers. What we want is a room full of mathematical thinkers. And mathematical thinking at its best is not always in a hurry. Next time on Show Me the Math Receipts, we're going somewhere that might make some people a little uncomfy. And that's exactly why we need to go there. So come back for episode 13. My name is Asali Smith. This is Show Me the Math Receipts. And until next time, teach boldly, protect student thinking, and always keep your math receipts.